Hello and welcome to today's video. Today we're going to be trying to solve Cambridge O-Level 5070 Paper 1 Specimen Paper for examinations upcoming in 2023. Today I'm going to be going through the multiple choice paper or paper 1, and we're going to be trying to solve through the 40 multiple choice questions that are there. Each question consists of 40 marks and calculators are allowed in this question paper. So without any further ado, let's get started with the first question. So first question is stearic acid has a melting point of 69 degrees. A heated sample of pure stearic acid is cooled and the temperature is recorded every minute for 30 minutes until a graph is shown below. So this is the result graph. So which process occurs between 8 to 12 minutes? Alright, so we know that we have the melting point of 69 degree Celsius, and we can see the graph is going from the top to the bottom, or from a greater value to a lesser value. That means that this is a cooling curve and not a heating curve. And it only has one flat line. That means we do not have the gaseous state. So the graph starts from liquid and then it goes up. And moreover, we have 69 degrees Celsius as the melting point. So if we go ahead and draw a line to the flat, we can see it's directly below 70. So we can say this is 69. So we can deduce that everything above 69 is still liquid, and over here it's still solid. And in between, this is where the change of state occurs. So we can say change of state, and over here we are going from solid to liquid. But over here it is a cooling curve. Okay, so it's a cooling curve. So that means that we are actually taking a look from liquid to solid. Alright, so now the question asks what process occurs between 8 to 12 minutes. So again, if you draw a line, this is 8 and this is 12, and we have to state what's happening over here. So it's from liquid to solid. So we know liquid to solid is freezing. So the answer is C. Okay, moving on to the next question. Which statements are correct? The volume of a gas at constant pressure increases as the temperature increases. So we have to deduce something. So when you're increasing temperature, kinetic energy among gas particles increase and they start moving more. So if this is a gas container, the particles will hit the container more often than usual. That means this particle will exert a pressure. So yes, statement 1 is correct, that pressure will increase if we increase the temperature of a gas that's enclosed in a container. Moving on, when pressure of a gas is increased, the particles move close together. So if you go ahead and plunge this lid and you press down, the particles are going to be squished more packed. Okay, so the particles are going to become more packed inside this. So yes, the particles will come close together. So statement 2 is also correct. Followed by the pressure of a gas at constant volume decreases as temperature increases. So this is literally opposite of statement 1. So that means this is incorrect. So it asks us which statement is correct. So our correct answer is going to be B, statement 1 and statement 2. Let's go ahead and take a look at the next question. Which substance would diffuse more quickly? Alright, so we have carbon dioxide, so let's write CO2, CO2, and neon is an E and Ne. So first of all, diffusion depends on two factors. One is temperature, and the other is molecular mass. or basically the MR or AR of a compound. So let's first take a look at temperatures. So we can see 25 degrees Celsius and 25 degrees Celsius, and it asks us which one will diffuse more quickly. So since these are at higher temperatures, option A and option C can be eliminated. So we remain with carbon dioxide and neon. The next part is to determine the molecular mass. So for carbon dioxide, its carbon is 12 plus 2 into 16. So it's 12 plus 32 is going to give us 4, and we have 4. So it's 44. Now we have to find out neon. So for neon, we have to go directly to the periodic table provided to us by Cambridge. So if you take a look in the periodic table, neon has a mass of 20, or the AR of neon is 20. So neon has a smaller molecular mass. So the less heavy a substance is, the more readily is going to diffuse. So the answer is going to be D. Okay, moving on to the next question. Which diagram shows the arrangement of particles inside a balloon containing a mixture of gases nitrogen and oxygen? So we have nitrogen atom and we have oxygen atom as defined in the side key. So let's take a look at all the gases. Okay, so nitrogen atom. So nitrogen has a molecular mass of, let's say, it's according to the periodic table 14, and oxygen is 16. Okay, and then followed by, we've got the diatomic molecules. So nitrogen is N2, oxygen is N2. So D is oxygen and nitrogen. So this forms nitrogen dioxide. So we can easily say option D is eliminated and option A is eliminated, since these are monoatomic. So the only two options that remain are over here, B and C. So we can go ahead and deduce from nitrogen atom and oxygen atom which one is going to be the correct one. So obviously nitrogen has a lighter molecular mass compared to oxygen. So our obvious answer is going to be B, since oxygen is at the bottom and nitrogen is at the top, since it has a lower molecular mass compared to oxygen. So oxygen sinks down. So question number 5 says the ion Q2 plus has 3 complete shells of electrons. So this ion has 3 complete shells. That means all of these shells are complete. So this has got 8, this shell has got 8, and this shell has got 8, and this shell has got 2. What is Q? Now since it's plus 2, that means it's from group 2. So it's going to have another shell, which is technically not present. I can't really draw a proper circle. Okay, it's good enough. So we have 2 at the bottom, right? So since it's an ion, we have to take a look at the normal electronic configuration now. Since it's got 8, 8, 2, and 2, the electronic configuration can be placed at 8, 8, 2. So it's got 16, 10, 19, 20. So the total number of electrons is 20. And if you go to the periodic table, calcium is 20, 40. So this is calcium. So our answer is calcium. Okay, so fluoride ions contain more electrons than sodium ions. So since it already mentions ions, so we can easily go ahead and say fluoride has 9, sodium has 10. And fluoride also has 10. It's not going to be 9 because it's an ion. So since fluoride is a non-metal and it's an ion, so fluoride is definitely going to have 10. So it says more. So this is not an option. Moving on to the next statement, the sodium ion contains more neutrons than fluoride ions. So neutrons. So let's see. So we have, for fluoride, we have 10 neutrons, so it's 10. If you subtract 21 and 11, you're also going to get 10. So this is also incorrect. The two ions contain the same number of electrons as each other. So yes, this is a option. The two ions contain the same number of protons as each other. We've got 9 over here and we've got 11 over here. So the answer is wrong. So the correct answer is going to be C. Okay, two isotopes of chlorine, chlorine 35 and chlorine 37, are present. Using these isotopes, how many different relative molecular masses are possible for the compound with molecular formula C2H3Cl3? Alright, so Cl3. So now let's try to go ahead and do some probability. So we've got 2, that means, yes, obviously these have different masses. So we can form a compound with 3 chlorine. So there are 3 chlorine present, Cl, Cl, Cl. That means it could be 35, 37, 35. It could be 35, 35, 37. It could be 37, 37, 35. Or let's say it could be 37, 35, 37. And we're not going to consider all of them as 35, 35, 35 or 37, 37, 37 because it says different molecular masses are possible. So we are not going to consider 35 all and 37 all. So the answer is going to be C. Alright, so let's move on to the next one. What happens to an atom of group 2 element when it forms a compound with oxygen? So group 2 loses 2 electrons because it forms a charge. So let's say magnesium, it's going to form a charge of 2 plus. So let's say it bonds with 2 atoms of oxygen. Technically no, because oxygen is from group 6, so it's going to gain 2 electrons. So this is obviously wrong. It receives 2 electrons from an atom of oxygen. Will it receive? Metals never receive, so it's going to be wrong. It shares. So magnesium or anything from group 2 is a metal. Metals never receive electrons from nonmetals. It always loses or ionizes. So this is also going to be wrong. So the only answer is going to be D. Alright, moving on. Moving on. Ethane, C2H6, and ammonia are covalent compounds. The dot and cross diagrams are shown. Okay, which statements are correct? A molecule of ethane contains twice as many hydrogen atoms as a molecule of ammonia. So let's count. So we've got ethane, we've got ammonia. So we've got 1, 2, 3. So we've got 3 hydrogen. 1, 2, 3, 4, 5, 6. So H is 6. So yes, statement 1 is correct. An unreacted nitrogen atom has 5 outer electrons. So let's consider hydrogen these dots. So we have to go ahead and count nitrogen. So it's 1, 2, 3, 4, 5. So yes, statement 2 is correct. Moving on, in statement 3, in a molecule of ethane, the bond between carbon atoms is formed by sharing 2 electrons, 1 from each carbon atom. So as we can see over here, we've got 2 electrons shared by 2 carbon atoms. So to make things easier, if we draw a structured formula of ethane, I actually drew a double bond. So if you draw a structured formula with hydrogens attached to it, so we've got 1, 2, 3 carbon, 1, 2, 3 that are shared. So 1 carbon from here and 1 carbon electron from here. So 2 electrons are being shared for this single bond. So yes, statement 3 is also correct. So the correct answer is A. Moving on, in number 10, a compound contains 70% by mass of iron and 30% mass by oxygen. What is the empirical formula? To make things easier, we obviously have the ARs given to us. So let's go ahead and try to deduce the empirical formula. So we've got iron, which is going to be Fe, and we've got oxygen right here. So first we write the masses. So 70 and 30% by composition. So how do we know it's exactly 70? Well, 70%, which is 70 by 100, is out of 100, right? So that means if we cancel each other out, we basically have 70 grams. So we know that the mass is fixed 70. Then next we are going to write the AR. So it's 56 and we have 16. So we can easily go ahead and use a calculator. Okay, so we've got our calculator right here. So we do 70 divided by 56, which is going to give us 1.25. Then we have 30 divided by 16, which is going to give us 1.875. And then we are supposed to divide by the smallest ratio. So we've got the moles, now we have to divide by the smallest ratio. So this is obviously the smallest ratio, so we're going to have 1. But then you have to divide 1.25 and 1.875. So let's go ahead and do that right now. So we've got 1.875 divided by 1.25, is going to give us 1.5. Now, here is the trickiest part. 1.5, so you cannot, like, this is a very far off value. So if you draw a number line, it's over here. But we have to achieve a whole number, right? So that means we have to use trialing and erroring method. So let's multiply 1.5 times 2. We're going to start with 2, and then we're going to move on as much as required. So you already have a whole number. That means we don't need to multiply it further. So if you multiply this by 2, you obviously need to multiply this by 2. So the final empirical formula is going to be Fe2O3, which means our answer is going to be B. Moving on to the next problem. The equation for the reaction between ethine and oxygen is shown. When the equation is balanced, what is X? So we obviously know that for carbon to be balanced, we have to put the exact number of carbon. So Y is definitely 2. And for hydrogen, Z is definitely 1. So if Y is 2, the total number of oxygen is going to be 2 times 2, 4 plus, we've got Z is equal to 1, so 4 plus 1, which is going to be 5 moles of oxygen. So definitely the answer is going to be D. Since we are having 5 moles of oxygen, we are going to put 5 over here. Okay, moving on to the next problem. 25 grams of hydrated copper to sulfate crystals are heated to produce anhydrous copper to sulfate and water. What is the mass of anhydrous copper to sulfate formed? So we have anhydrous copper to sulfate here, and we've got copper to sulfate here. So obviously we're going to be using molar ratio. So we have the mass given for the hydrated copper to sulfate. So let's find out the moles. So the moles is going to be mass divided by the MR. So MR of copper to sulfate is 160 plus 5, and H2 is 18. So 5 into 18. Okay. So we're just going to use calculator. So it's simple 160 plus 5 into 18. So it's 250. So if it's 250, we can divide 25 by 250, which is 0.1. So 0.1. So now we're going to find the molar ratio. It's 1:1. So if you write 1:1, and we know this, but we don't know this. So therefore, the moles of copper to sulfate, or anhydrous copper to sulfate, is also 1:1. So now you have to find out the mass. So mass is against moles equal to mass by MR. So mass is moles times MR. So we're going to be writing the moles, which is 0.1, and MR of copper to sulfate is 160. So we're just going to take out the calculators again into 160, which is going to give us 16 grams. So our answer for number 12 is going to be B. Okay. Moving on to the next question, the relative formula masses for 4 compounds are given. So these are relative formula masses. A student has 1 gram of each sample. Which sample contains the highest number of moles of oxygen atoms? So what is moles? Mass times MR. Oops, sorry, it's actually mass by MR. And since it's only 1 gram of a sample, we have to multiply it by 1, which is basically the same. So it's only going to be moles is mass by MR. So let's do it for aluminum, or this aluminum compound right here. So for Al2O3, it's going to be 3 into 16 divided by, we have to know the MR of aluminum from the periodic table, which is given as 27. So it's 27 times 2 plus 3 times 16. So we are going to be going ahead and using our calculator. Now, since this is a bigger calculation, I am going to be going ahead and using a scientific calculator off screen, so I'm not showing it. So it's 3 times 16. So if we calculate, we are going to be getting an answer around 4.7 for aluminum oxide. Next is copper oxide. So let's write CuO, and for copper, the relative formula mass is 80. Actually, this and this is the exact same thing, so I really don't think we have to do this calculation because you are going to be getting the same result. So for copper, it's going to be, we're going to take a look at the periodic table. So copper is 64, so we don't have to do this. Oxygen is 16, and this is 80. So we can easily do is 16 divided by 80, which is 0.2. Okay, it's better we actually write it so that we can later relate onto it. So we've got 0.47, we've got 0.2. Next, we have got 4 oxygen over here. So for H2SO4, it's going to be 4 times 16 divided by 98, or the MR. So it's going to be 4 times 16 divided by 98. So you're getting an answer of 0.65. Make sure to try these in your calculator while you're performing the paper. Next is nitric acid, or HNO3. So in this case, oxygen is 3 into 16 divided by 63. So we can type 3 into 16 divided by 63. We are going to get 0.76. We have 0.76. So it says highest number of moles of oxygen atoms. That means our clear answer is going to be D. Moving on to the next question. 50 cm cube of 0.01 mole of silver nitrate is added to this much of sodium iodide in a beaker. After a reaction, solid sodium iodide is present in the beaker. What else is present? So over here we have to find out the excess reagent and the limited reagent. That means after the reaction, we're going to obviously have the product, and we're going to have the excess reagent as well, or the unreacted amount of the reagent. So we have the information for both, so we have to find out by calculation and then find out by molar ratio. So it's very easy to do. So first of all, we have to find the equation. So we have AgNO3, or silver nitrate, reacting with sodium iodide to give sodium nitrate. Oh, okay, yeah. And silver, so AgI. So this is a balanced equation. There is nothing more else to balance, and everything is in a 1:1 ratio. So now our first job is to find out the moles of silver nitrates. So AgNO3. So moles is going to be concentration times volume. So it's 50 by 1000. Since it's given in 50 cm cube, we need to convert it to dm cube. So that's the reason I'm actually dividing it by 1000. So 50 divided by 1000. So our moles is going to be 0.005. For sodium iodide, we are going to do it the exact same way. So we have 0.05 moles times 150 by 1000. So 0.05 times 150 by 1000. So this is going to be 0.075. Oh, it's actually 0, 1, 2, 3, yeah, 0.075. Okay, so now we have the molar ratio we have to consider. So let's consider silver nitrate and sodium nitrate. Okay, you know what? Let's consider sodium iodide and silver nitrate. Since we're trying to find out the reagents that are in excess, so we're going to consider only the reactants. We do not need to consider our amount of products. So let's go ahead and rub those out. So for silver nitrate, we are going to be considering 0.005 over here x. So 0.005 required NaI. So this much is a required NaI, but we took this much. So if you consider 1, 2, 3, 1, 2, 3, this is in excess, right? This much is required, but we took more than that. That means sodium iodide is in excess. So for our number 14, aqueous sodium iodide is going to be present, and as well as sodium nitrate. Oh, okay, so we have what else is present. Aqueous sodium iodide and sodium nitrate. So we have sodium nitrate and we have sodium iodide, which was the excess product, not silver iodide. So that's my mistake. Not silver iodide, we have sodium iodide and we have sodium nitrate. Sodium nitrate and sodium iodide is present. So the correct answer is B. Took a lot of time than required. Anyways, moving on to the next question. We have carbon electrodes are used for electrolysis of aqueous copper to sulfate. What observations are made? So you have to remember carbon electrode is inert electrode. So that means this will not take part in reaction. Moving on, we have electrolyze aqueous copper to sulfate. So we have copper. So this will go at the cathode. And OH minus is going to go at anode, since sulfates are more reactive than the hydroxide ion. So sulfate is not going to be discharged. OH is going to be discharged. So let's first take a look at the anode. Obviously, electrodes are never going to increase in mass since we're using inert, so the answers could be A or B. So C or D are eliminated. Now let's take a look at cathode. So obviously at cathode we're going to find copper. So yes, a pink solid will be deposited at the cathode. And since copper is moving away from the aqueous copper to sulfate electrolyte, the blue color will definitely fade away. So our answer is going to be A. Okay, let's move on to the next question. Electrolysis is used to plate a metal coin with silver. The coin is used as an electrode in a suitable electrolyte. Which row is correct? So we have to do electrolysis. We're going to be electroplating a metal coin. And we have to remember that the anode always breaks down. So anode breaks down. So that means the silver has to be present in the anode. So this coin will definitely go at the cathode. So A and B can be eliminated among C and D. And the electrolyte must always be in aqueous form or in molten form. And we know from salts that any silver halides or lead halides are not soluble. So this is definitely not an aqueous compound. So the answer is going to be D. All nitrates are soluble. Okay, let's move on to the next question. An endothermic reaction has an activation energy of X. Which reaction pathway diagram is correct for this reaction? Okay, so let's go ahead and deduce what we can find. When a reaction is endothermic, it gains heat from the surroundings and it has more energy compared to the reactant. So the products are going to have more energy than the reactants. So we can see products has less energy in B and C. So we can eliminate these. Now we have to find activation energy. So activation energy is the total energy from the reactants to start up the reaction and then go all the way up to the peak point of the reaction before the products are formed. This right over here is the enthalpy change, or the amount of heat energy absorbed if it's an endothermic, or radiated if it's an exothermic. So our definite answer is A. Let's move on to the next question. So number 19, the formation of a liquid from liquid water from hydrogen and oxygen may occur in 3 stages. Okay, which stages are endothermic? So endothermic refers to so an endothermic reaction refers to bond breaking. So if there is a bond, you need heat energy to break the bonds. So that means yes, number 1. Number 2 is a bond formation, and number 3 is also a bond formation. Basically, number 3 is nothing. It's from gaseous to liquid, so it's also, yeah, so options 2 and 3 are incorrect. Only option A is related to something endothermic. So number 19 is going to be B, since bond breaking occurs, and bond breaking requires energy to be applied to the bonds, and energy is absorbed, so the reaction is endothermic. The next question is related to the rate of reaction. So in number 20, in 4 separate experiments, 1, 2, 3, and 4, nitric acid is added to excess of marble pieces, and the volume of carbon dioxide gas formed is measured. In all 4 experiments, the same volume of nitric acid is used. So this is obviously limited. And the next is the concentration or the temperature, or both or both concentration and temperature of nitric acid are changed. So either is changed. The results of the experiment are shown on the graph. Which statement is correct? Okay, so we have to deduce them one after another. A lower concentration of acid is used in experiment 3 than in experiment 1. So the concentration is obviously going to be affecting the rate of reaction. Now do note, all of these reactions come to a steady point at a certain. So in this case, in number 1, the steady point is achieved a bit early since it has the highest rate of reaction. Let's use a different color. So the steady point is achieved, but for all the others, they are received around the 5. So that means the acid is acting as a limited agent. Now let's take a look at concentration. So obviously, increasing concentration will also increase the rate of reaction. So concentration will increase the rate of reaction. So as we can see in number 1, let's consider 1. So for 1, or for 1 minute, we have around 100 volumes of gas produced. And for graph 3, for 1 minute, we have less than, let's consider this 50. So obviously less acid or less gas is produced. That means yes, statement 1 is correct. A higher concentration was used since in experiment 1, the rate of reaction is faster compared to the graph of 3. So that means our answer could be A, so let's circle this for now, and let's deduce the others. Experiment 4 is faster than experiment 3. Definitely not. So if we take a look at the graphs one more time, so I'm going to be cleaning up the graphs a bit. So let's go ahead and consider experiment 3. Again, for 1 minute. In 3, let's consider 50. But for 4, let's use another color. But for experiment number 4, we can see much less of acid. Let's say 25 is produced. So definitely B is not an answer. Next, for option C, the acid used in experiment 2 is of a lower concentration than of 1. So let's see. For 2, let's go ahead and again take it. And for 1, Okay, so we can see that definitely 2 has a lower rate at 1 than equation or than graph 1. But we can also see that the graph is steeper and that the reaction actually reaches the point of steadiness before 1. 1 is still reacting at this point, whereas 2 has already reached the equilibrium or the steady point. That means no, 2 has a faster rate of reaction. It could be due to both temperature and concentration. So 2 is not, C is also not a answer or a solution. So number D, the temperature of the acid is same in both experiments 1 and 2. If the temperature of acids were same, then we had to obtain same volumes of the gas. That means definitely this is not the answer. So the answer is going to be A. Okay, so moving on to number 21. The equation shows a reaction for the manufacture of ammonia. Which change will decrease the activation energy for the reaction? So decrease the activation energy. Obviously, catalysts decrease activation energy. They don't necessarily decrease it, but they just lower the amount of activation energy that's actually required. So 21 is A. Moving on to number 22. A reversible reaction is shown. Okay, which increases the mass of the precipitate formed. So we need to know that the products must be higher in yield. So adding more water. So we can see that if we add more water, the equilibrium will shift to the right because there is no water in the right hand side or in the forward reaction. So if we change something in the equilibrium will try to fix itself by moving to the side that has less water. So definitely it's going to move to the right for number 1. For number 2, we have adding aqueous sodium hydroxide. So adding aqueous sodium hydroxide, we have a chloride and we have water. And we also have a hydrochloric acid in the reaction. So now let's imagine this equation or this reaction is constantly happening. HCl is deliberately formed and then the whole equation is going back to forming salt and water, right? So basically there is a neutralization reaction that's happening, right? So in HCl, if we add sodium hydroxide, it's a base. So it is going to be forming NaCl, a salt, and it's going to be forming water on the same side. That means HCl is going to go technically down and sodium hydroxide is going to be added. That means sodium hydroxide is a reactant over here and HCl is a product. So again, the equation will go to the forward version, or it's going to go forward. It's going to favor the forward reaction since we can also see water is increased. If you add sodium hydroxide, one of the reasons is it's a reactant and it's going to be increasing the products if you add more of the reactant. The second reason is, as we can see, water is formed when you add sodium hydroxide. And that's going to increase the concentration of water. And we can see that water is actually a reactant. That means it's going to prefer the forward reaction. So yes, 1 and 2 can both be correct. Next is adding dilute hydrochloric acid. Obviously that's not going to be an answer because if we add more, it's going to shift to the left to fix the equilibrium and go to a less amount of acid. So the correct answer is A, 1 and 2. Next question says sulfur trioxide is produced by the reversible reaction shown. So right here, which change in condition will produce a greater amount of sulfur trioxide at equilibrium? So adding catalyst will not change the concentration because obviously, it'll just lower the activation energy. Increasing pressure. So we can see we've got 2 and we've got 1 mole. So in total we have 3 moles or 3 particles. Over here in total we have got 2 particles. That means if we increase pressure, the equilibrium will prefer side with less pressure, or that means less number of particles. Less number of particles means less pressure. So yes, B could be a possible answer. Increasing temperature, right here it's a exothermic reaction. That means this side has more temperature. So if we increase the temperature, the equilibrium will shift to the left-hand side, to the endothermic part of the equation. So this is not an answer. Removing removing some of the sulfur dioxide and oxygen. So if we remove the sulfur dioxide and the oxygen, obviously we are giving less amount of products. So the equilibrium is going to be shifting to the right. I apologize. It's actually going to be reactant. So the equilibrium is going to be shifting to the left-hand side in order to increase the amount of reactants. That means D is not also going to be an answer. So our answer is going to be, the answer is going to be B, increasing pressure. Moving on, iron 2 ions react with chlorine. Which statement about this reaction is correct? Okay. Chlorine is reduced by iron 2 ions. So we can see chlorine is gaining a electron. So yes, chlorine is definitely getting reduced by the iron 2, and iron 2 is getting oxidized since it's losing an electron. Chlorine is a reducing agent. So if chlorine is reducing itself, that means it's not a reducing agent, because we know that a reducing agent will reduce something else, but it's going to be oxidized itself. But chlorine never reduced iron. Iron was oxidized. That means this is not going to be an answer. Iron 2 ions are reduced by chlorine. No, chlorine is not reducing, it's actually oxidizing. So this is not an answer. Iron 2 ions are the oxidizing agent. So iron 2 ions are oxidizing agents. Okay, no, iron is actually reducing chlorine. So it's reduced. So since it's reduced, then iron is a reducing agent. So our definite answer is A. Which reaction involve oxidation and reduction? Chlorine gas reacting with aqueous potassium iodide. So Ki plus Cl2. So it's KCl plus I2. So we're talking about redox. So yes, number 1 is a redox reaction. Dilute sulfuric acid reacting with magnesium. So Mg plus HSO4. Oh, okay, I didn't explain why chlorine this is a redox. So you can see iodine is losing electrons. So this is oxidation. Chlorine is gaining electrons from potassium. So it is a reduction. So that means this is a redox reaction. Same goes for equation 2. We can see that magnesium will lose electrons to sulfuric acid to form magnesium sulfate. And hydrogen is going to be gaining electrons from the sulfuric acid, or it's going to gain back its electron and form hydrogen gas. So 2 is also a redox reaction. So let's follow by number 3. Dilute hydrochloric acid reacting with aqueous sodium hydroxide. So we have dilute hydrochloric acid reacting with NaOH. So we can see we are forming NaCl. So we have a salt form, which is an ionic. So nothing happens with chlorine and oxygen, plus water. So we can see hydrogen is reduced. So that means only reduction occurs. There is no oxidation. So the answer is B, since 1 and 2 are the only redox reactions. In equation 3, only redox occurs. So that means this is not an answer. Okay, so moving on to number 26. Which statement about weak acids are correct? They partly dissociate in an aqueous solution. Yes. They do not react with alkalis. No. All acids react with alkalis. They do not react with metals. No. Weak acids do, but they do it slowly. Different solution pH value ranging from 0 to 2. No. They are much more closer to 7, like 5 or 6. So the answer is A. Okay, so 27. A colorless aqueous solution of pH 13 is tested separately with methyl orange indicator and thymophoethane indicator. Which row is correct? Color with methyl orange. So since it's pH 13, it's alkaline, so obviously it's going to be yellow. And will thymolophthalane or whatever. So we have blue and we've got colorless. So this is something we do have to know. So always remember that in an alkaline solution, we're going to get a blue color. For an acidic solution, we're going to get a colorless solution. It's almost like phenolphthalein, but it's much more less toxic. And unlike we get a pink colored phenolphthalein, over here we're going to have a blue solution. So the answer is definitely going to be C. Moving on, which pair of reagents is suitable for preparing a pure sample of copper 2 chloride crystals? So copper 2 chloride is a soluble salt, since it's a chloride and all chlorides are soluble except silver and lead. So definitely the soluble salt. That means if it's a soluble salt, we can either add an acid and alkali, which is titration, or we can add a soluble plus insoluble, which is neutralization. So let's try to find out. So aqueous copper 2 nitrate and aqueous sodium chloride. Okay, so sodium chloride is a salt, so it's definitely not going to react with nitric acid. So this is gone. We've got copper and we've got sodium chloride. Again, sodium chloride is a salt and it's never going to react with copper, and ready-made copper never reacts with anything. Next we have copper and dilute hydrochloric acid. Again, it's a dilute acid and copper is a very low reactive metal, and just normal copper doesn't react. Only copper compounds readily react with dilute acids. So finally, we've got copper 2 oxide, which is insoluble and a soluble acid. So the answer is going to be D. Element X forms an oxide of formula this. In which group of the periodic table is X likely to be found? So X is 5 over here. So X has a 5, so it's sharing 5 electrons. It has a 5 electrons in its valency shell. And if it's sharing 5 electrons, that means it must be a charge of -3 in order to form ionic compounds. So a charge of -3 is formed by group 5 of the periodic table, or the elements of group 5. So the answer is going to be C. Okay, moving on to number 30. The diagram shows the structure of an alloy. Which statement about alloys is correct? Alloys can be only formed by mixing copper or iron with other metals. No, they can be formed with any metals. We have carbon and iron are the only two elements in stainless steel. No, we have chromium, we've got nickel. So this is not only it, we've got zinc. In an alloy, there is an attraction between positive. Okay, no, alloys are a mixture. The alloy brass has a chemical formula. Obviously, anything has a chemical formula. So, okay, no, the alloy brass does not have a chemical formula because they're a mixture. They're not chemicals. So this is actually not the answer. An alloy there's an attraction between the positive ions and a sea of delocalized electrons. So actually, this is kind of true. Alloys are made of metals, and metals have positive ions surrounded by delocalized sea of electrons. So the answer is actually C. I'm sorry, it's really not D. I really didn't notice delocalized electrons. So since it's a metal and it has a sea of delocalized electrons, the answer is going to be C. Which compound has the lowest percentage by mass of nitrogen? Okay, so over here we've got nitrogen is 2. So it's 2 times 14 divided by the mR times 100. That's how we find the percentage by mass. So it's 2 times 14 divided by 60 times 100. So we have 46.67%. Moving on for this one, we again have 2 times 14. We have a higher mR, which is 132 into 100. So it's going to be 2 times 14 once again. And I'm just doing it on a calculator off camera. So it's 21.21%. Then we've got this compound, and we have got a 3 with nitrogen. So it's going to be 3 times 14 divided by 149 times 100. So we're just going to write 149 and it's a 3. So it's 28.19%. And finally, we've got this. We've got 2 nitrogens, so 2 into 14. We have got 1 nitrogen here, 1 nitrogen here. Divided by 80 times 100. So it's 2 into 14 times 80 times 100, which is a 35%. So the highest mass is right here, or the highest percentage. So the answer is going to be A. Okay, so now we enter the world of organic chemistry, the last part of any GCE examination. Okay, so number 32 shows the diagram shows structure of 5 hydrocarbons. Which of these 3 hydrocarbons are isomers of each other? So let's consider 1. So it's 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So it's pentane. Okay, so we've got pentane on the board. Okay, so let's check 2. So it's time to first count the long chains. So we've got 1, 2, 3, 1, 2, 3, 1, 2, 3. So okay, so this is definitely 3. 1, 2, 3, 4, 5. So we've got 5. So yes, this could be an isomer. We've got 3, so it's going to be prop 1. So we've got 1 branch, and we've got 1 branch. It's got 1, 2, 3, 1, 2, 3. So it's going to be 2-dimethyl ane. So yes, 1 and 2 are isomers. 1, 2, 3, 4. So we've got 4 carbons. So this is definitely not an isomer. Move on to 4. 1, 2, 3, 4, 5. Yes, we have got 5 carbons. It could be an isomer. And we have the 1, 2, 3, 4. 1, 2, 3, 4. So it's a bute. We've got the branching on 2. So it's a bute 2 dimethyl ane. So yes, this is also... It's actually not prop 2, it's actually prop 2,2-dimethyl. It's not just 2. The reason is there are 2 dimethyls, but over here we have 1 dimethyl, so it's just butyl-dimethyl. So yes, 1, 2, and 4. 1, 2, 3, 4, we've got 4. So these 2 are isomers. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh no, these are not even isomers. They have 9 hydrogens among them. So the only isomers are 1, 2, and 4. So the answer is going to be 1, 2, and 4. So the answer is A. Okay, so moving on to the next question. The diagram shows the fractionating column for the separation of petroleum, which explains why fraction R is collected above fraction S. Okay, boiling point of R. So obviously the liquid with the higher boiling point is distilled over first. That's the basic concept of distillation. So the boiling point of R compared to S is definitely smaller because it's got a lesser boiling point. So it's going to be evaporating or boiling over first. The liquid with the lower boiling point is distilled over first. So yeah, liquid with a lower boiling point, so it's smaller than S. The average molecular mass, it's definitely obviously it's going to be smaller than S. The reason is obviously with a lower boiling point and a lower mass compared to S, the liquid can easily boil and go above S so that it can be summed up with R. So the answer is D. Which compound is an alkane? So the general formula of alkane is CnH2n plus 2. So we've got 31 and we've got 33. So this is definitely not an alkane. 31 and 60, also not an alkane. Or is it? 31 times 2 plus 2 is 64. So this is also not correct, since we get 6. This is an alkene. So we've got 31 times 2 is equal to 62 plus 2 equal to 64. So yes, this is an alkane. Okay. Which row correctly describes alkenes? So alkenes are definitely unsaturated. Only alkenes are saturated. What unsaturated and saturated means is in saturated compounds, it's difficult for other compounds to get in. That's why Alkanes do not go under halogenation. Only alkenes do go under halogenation. Alkanes do go under halogenation, but you need to use UV light in order to break or sever the bonds of carbon. But in alkanes or in alkenes, it's actually a bit easier. So result when shaken with aqueous bromine. Yes, there will be a decolorization. So the answer is D. This is actually the test for alkenes and alkanes. Alkanes generally are unreactive with liquid bromine. They only have to be done with UV light. So alkenes are much more readily reactive with halogens. Oh, we're almost at the end of this paper. So let's move on to question number 36. A carboxylic acid with the molecular formula this reacts with an alcohol with the molecular formula this to form an ester. Okay, great. So we've got a carboxylic acid. So it's got 1, 2, 3, 4. So we've got a carboxylic acid, which is reacting with an alcohol, which is C. Okay, so this is it. H8, 1, 2, 3, 4, 5, 6, 7, 8. All right, and we also have the hydrogens over here. Oh, sorry, there's nothing. There's going to be nothing on top of oxygen. Okay, so now it's going to be forming. So from the acid, we are going to be removing this, and from the carboxylic acid, we're only going to be removing the OHs. Okay, so over here we have the structural compounds given like this. So we have to do a bit of hardware work, I guess. So obviously, while we are doing organic chemistry, we are taught that when we are reacting a acid and a alcohol to form an ester, the acid part comes first, followed by the alkaline part. So let's go ahead and try reacting these. So obviously hydrogen and these are severed. So you're going to be first writing the acid parts, which is, we've got hydrogen over here, hydrogen over here, hydrogen over here, hydrogen over here. So we've got 2 hydrogen over here, 1, 2, 3, 4. And that's when we're going to be writing the the acid. So this is the alcohol, and we've got the acid. So we've got 1, 2, 3, 4. And the rest goes on like that. So as we can see, we've got 1, 2, 3. We've got 1, 2, 3 over here. And we have one of the carbons that's reacting or forming the ester linkage. So we've got ester linkage. And then we've got the alcohol part. So we have 1, 2, 3 carbons, 1, 2, 3 carbons. We've got 3 hydrogen, 3 hydrogen. We've got 2 hydrogens, we've got 2, and we've got another 2 hydrogen. We have also got 2. So the answer for the reaction of the ester is going to be B. So we've got a repeating unit of a polymer shown for this question. How would the monomer be arranged for this particular repeating unit? So obviously in a repeating unit, the repeating units are obviously exactly the same. Okay, so let's first start with A. Hydrogen, carbon. So we've got a hydrogen over here and a compound of CH3 over here. We've also got a chlorine and a bromine over here. So yes, A could be a possible answer. For the second option, we've got a CH3 group, but we've got an H and we've got a chlorine group. So this is definitely not the answer. For the following one, we've got a bromine group and we've got a bromine group, but we have a chlorine here, but we've got a carbon group over here. So this is also not the answer. Moving on, we've got a carbon and we've got hydrogen, but over here we have got a carbon group, but we have a chlorine group. This is definitely not the answer. So our only answer is A. Moving on to the following. When heated, magnesium reacts with oxygen to form air in the air to form magnesium oxide, a white powder. The student investigates the changes in mass occur in the shown. Okay, which set of apparatus is suitable for this reaction, for this investigation? So metal tongs. So yes, we need magnesium ribbon, since magnesium is highly reactive. So we have got the burning magnesium. So we've got number 2, magnesium, and we've got air. Now we have to realize one thing. We're trying to react the air with magnesium. So we're just definitely not going to light it up directly, right? So option 1 alone is not going to be an answer. But it's still an answer, so we're going to consider it. But for number 2, we've got heating, and we've got air that's flowing through in. So this is definitely one of the answers. For number 3, magnesium, and we've got a cubical club, and then we've got metal tongs to react it with, and enclosed space for the air. So 3 is definitely the answer. Now, why can't 1 be an answer? Because there's readily oxygen available in the air, and we just want a specific volume of magnesium to react with it. So definitely 1 cannot be an answer. So in this case, our answer is 2 and 3. Okay, so for number 39, a student uses paper chromatography to find the RF values of iron 3. The results are shown. To make the spot containing the more visible, the paper is sprayed with the aqueous sodium hydrogen and the precipitate of iron 3 hydroxide forms. Under the conditions of the experiment, the RF value of Av3 is given by... So let's go ahead and consider the RF value. So we've got the baseline. So remember, RF value is distance of the smaller value, which is the solution that goes up from the baseline to the top, by the bigger value. So small by big. So the bigger value is definitely y. So therefore, the RF value for Fe3 plus is x by y. So the options containing y by x can easily be eliminated. So y by x is eliminated. And the color of the precipitate is, so we have iron 3 hydroxide. So iron is a reddish brown precipitate. Only iron 2 gives a greener precipitate. So for number 39, the answer is going to be B. Last but not least, for this entire paper, tests on aqueous solution of an unbound compound of P is shown on the following table. Which ions are present in P? So the test for aqueous sodium hydroxide, green precipitate soluble in excess to give a green solution. So this is a sign of chromium ions. Now you might be thinking, why not iron 2? Iron 2 gives a dirty green color. So this is definitely chromium. Since we have iron and chromium both present, we have to take a note in the word dirty with the word green. Dilute nitric acid added to aqueous barium nitrate. So barium means sulfate. No questions asked, sulfate. So yes, we're going to add insoluble barium sulfate. Diluted with aqueous silver nitrate, so we have no precipitate formed. And that also confirms that there's no iron formed in this and no chlorine formed. So the only answer was D and B, and there is no iron, so the answer is going to be B. So guys, I hope you enjoyed today's lesson in containing these question papers. I hope I can bring more and solve more question papers. But since exams in 2023 are a must, I thought I would solve this specimen paper from Cambridge O-Levels coming from 2023. Anyways, I hope you could learn something from this video, and I'll catch you up in the next solution.